In this video, we are going to cover the HL part of this chapter of E1. In previous video, we completed the SL part where we talked about the energy levels and atomic physics related structure of atom. In that, we talked about two postulates of Bohr, where Bohr said that electron has to be orbiting in a orbit of a fixed radius, which represents a unique energy level. Now, the third postulate to his model was the angular momentum of electron orbiting the nucleus must be quantized, and it is given by mvr is equal to nh by 2 pi, where n is an integer 1, 2, 3, which can represent different angular momentum. Angular momentum depends on three factors: mass, velocity, and the radius. So this formula is very much important. And using this formula, we can derive some unique equations for the radius and how it depends on the value n, and also the total energy of the electron orbiting a nucleus. Now we are going to talk about this derivation. This derivation is very much important. This is quantization of angular momentum derivation. This is only we are doing it for the hydrogen atom, where it is very simple. Hydrogen atom has a positive nuclei, a positive proton, and an electron orbiting the nucleus. So both have charge E. One has negative charge, the other has positive charge, but at the distance, let that distance be r. Let this velocity of this electron also be v. Okay. Now, if I start with this model, we have mvr is equal to nh by 2 pi, where we know all the constants, and we are intended to find a radius and the energy of this electron. So these are the key points you need to measure. Remember how we will start. The first point that we are going to talk about is the centripetal force is equal to the Coulomb force of attraction. Because this is orbiting in circular motion, there has to be a centripetal force, and that centripetal force is none other than the Coulomb force of attraction between the protons and electron, and that will give us this equation mv square by r is equal to ke square by r square. Usually we know that Coulomb force is given by k q by r square, but here both the charges are same, so it will be ke square by r square. And that will, if you will take the r on one side, you will get mv square by is equal to ke square by r. Now that is just for the first equation. We'll keep the first equation right there, and then we'll use the Bohr's postulate mvr angular momentum is equal to nh by 2 pi, and we will square it. Once we square it on both sides, our intention of squaring is to find the mv square by r. So when we get mv square by r, it automatically, by moving some terms on the other side, we will get n square h square 4 pi square mr square as an equation. Okay. Then what we need to do, we need to equate 1 and 2. When we equate 1 and 2, we can rearrange the terms to find r, and we will get r in terms of n, where r is directly proportional to n square, because h 4 pi m, that is m is mass of electron, k e square, all are constants. So r is directly proportional to n square. So with each number n equal to 1, n equal to 2, n equal to 3, the r will increase by square of that distance. That's for the reason why we will see that all the orbits are getting greater and greater in radius with each increasing number. Okay. Then if I want to find the total energy relationship, I will start with kinetic energy and the electric potential energy. So that is ke square by r, and we can substitute mv square as ke square from 1. This is substituted from using the one equation, mv square is equal to ke square by r. And then we simplify this, we will get half 1 by 2 ke square by r. Now here what I am substituting is r here. Whatever r we got in the previous equation, we substitute that and we will get some relationship with the total energy and n square. So E is directly proportional to n square, and those are the two important relationships that we would like to remember. Okay, they ask most question like upon this. For example, if the energy is E2 upon E1 will be equal to, very simple, it will be 2 square upon 1 square, like that. Okay. No, it will be 1 by 2 square upon 1 by 1 square. So it will be 1 by 4, like that. Okay. So those kind of a question they usually ask. Now, all the other ones are attractive, and mostly the energy we consider is in electron volts. So that's the reason why we need to remember this formula. This is given in data book, but this is very important for this chapter. Okay. Then EV is equal to electron volt, this is unit of energy. We already know this. Now, whenever this is a ground state, remember that ground state is lowest energy possible, and ground state represents n equal to 1, where E1 is equal to negative 13.6 electron. Now, why it is negative? Because obviously the potential energy of attractive force is higher compared to the kinetic energy. If the kinetic energy becomes greater than potential energy, then the electron will escape the atom. Okay. Now, the first excited state does not represent n equal to 1, but rather n equal to 2. So that is 13 point. So when we calculate similar way some energy levels, you will find that the distance between two energy levels keeps on decreasing. Okay, so as the n increases, the gap between the energy level decreases drastically as n is directly or inversely proportional to 1 upon n square. Okay, so those are the energy levels. You can see the degree, there is a decreasing differences in energy. Okay, some energy levels for the hydrogen atoms are shown. Okay, now let's say how we can use this to find the solution to this equation. So there is a wavelength emitted in X transition X, and there is wavelength emitted in transition Y. Okay, and we are saying that they are asking like this. So we know that wavelength of X upon wavelength of Y. Now wavelength of X, how we know that wavelength is related to difference in energy by this relationship, and in this case the energy difference is E3 minus E1 for X. Okay, so it has to be Hc by E3 minus E2 minus E1 for X. Similarly for Y it is E3 minus E1. Okay, now if we cancel out the common terms, we will get E3 minus E1 upon E2 minus E1. Now we probably don't know the value of E3 even, but this is for hydrogen atom, so we can write this negative 13.6 3 square. The formula is nth energy is equal to negative 13.6 upon n square. So we will substitute that here. We will get a similar looking equation, that is 2 square minus 13.6 upon 1. Okay. Now since 13.6 is common, negative 13.6 is common in all the terms, we can cancel it out. We'll get 1 upon 9 minus 1 upon 1 upon 1 upon 4 minus 1 upon 1. Okay. Then we can do the cross multiplication and everything, which will give me minus 8 over 9 upon minus 3 over 4, which upon simplifying will give us 4 by 3, that is 32 over 27. So C is the correct answer. Okay, so this kind of a problem is expected to do that. Now speed of the electron and speed of this in n equal to 2 states. Now this is radius is given for n equal to 2 state, that there is 4 times the radius of n equal to 1 state. So we know that the relationship is mv square by r, and mvr is equal to nh by 2 pi, correct? So it means for us v is equal to nh by 2 pi mr. Okay, now nh, only n is changing, h 2 pi mr all are constants. So if we are talking v2 upon v1, then it will be 2 into h upon 2 pi, this is, and r is, let's say, r2. Similarly, this is 1 into h by 2 pi m into r1. So now in this case, what is happening is, okay, so what we are doing here is, this is r1 upon r2 which we will get, and this is 2. Okay, now in this case what will happen is, r2 is 4 times of r1, so this will be 4 times of r1, like this. So that will give us 1 upon 2 as an answer. Okay, so this is how we can expect questions from this unit. This is quantization of angular momentum related questions. Okay, so this completes our E1 with HL and SL part. Thank you.